In 2017, a collaborative effort of scientists from Princeton and Hong Kong yielded an incredible device that at first glance violates the fundamental laws of physics. A microscopic mechanism consisting of two toothed silicon plates spaced 100 nanometers apart was able to generate a small amount of energy, literally, from nothing. It would seem that such a phenomenon should grossly violate the law of conservation of energy, one of the fundamental principles of the universe's makeup. However, in fact, it is not as simple as that. The amazing device is based on the Casimir-Polder effect, discovered back in the middle of last century. Putting it simply, it boils down to this. If two thin plates are placed in a vacuum a very small distance apart, they will begin to be mutually attracted. The phenomenon is closely related to the Heisenberg's uncertainty principle, from which follows the existence of the so-called zero-point vacuum fluctuations. They are pairs of virtual particles that constantly appear at any point of the universe, by and large out of nowhere. However, their lifetime is only 10 to the power of minus 24 seconds, after which the particles disappear back into nothingness and the global balance is restored. At the same time, if virtual particles with any parameters are generated in open space, only those that have strictly defined wavelengths can be generated between the plates. Consequently, more numerous external particles press on the plates harder than internal ones. Just to illustrate, one can imagine that the space between the plates has a negative pressure. It's as if a little more substance were pumped out of the vacuum. The resulting mechanical tension can be transformed into an electric current, which is exactly what the Princeton and Hong Kong researchers did. And although the current was quite weak, it's the principle itself that matters. Because this way, our world receives energy virtually from nothing. Even a low-power source of inexhaustible energy is of enormous practical value.